Welcome to aminacademy.com. In discrete mathematics regarding probabilities, let us do some solving problem regarding Bayes theorem. Look at these examples. In a factory that produces bolts, three machines A, B and C are responsible for manufacturing 25%, 35% and 45% of the total bolts. Three machines totally produce 100% bolts respectively. The defect rates of these machines differ. Machine A produces 5% defective bolts, machine B produces 4% defective bolts, and machine C produces 2% defective bolts. A bolt is randomly selected from the overall production and it is found to be defective. What is the probability of likelihood that this defective bolt was produced by the machine B? Suppose three machines, they are producing different number of bolts, as well they are having different number of percentage of defective bolts. Suppose you are selecting randomly one bolt that is defective, that produced by machine B. What is the probability? Look at this. Let events B1, B2, B3 are represent the following. B1 represent bolt produced by machine A, that is B2 is machine B, B3 is machine C. Clearly B1, B2, B3 are mutually exclusive because not mixed and collectively exhaustive, meaning they are from complete partition of the sample space. The event E represent the bolt is defective. The event E occurs along B1, B2 and B3 respectively. Suppose probability of B1 is 25%, that is 0.25. B2, probability of B2 is 0.35. Probability of B3 is 0.40. Now again, P of E over B1, which means represent the probability that the bolt is defective given that it was manufactured by the machine A, that is P E over B1 first. Then similarly P of E over B2 is 0.04 because 4% defective, and P of E over B3 is 0.02, that is 2% defective. Hence by Bayes theorem we have, then hence the required probability is, look at here, we need the probability of defective bolt, that is from machine 2, that is B2 over E we need, which is equal P of B2 over P of B2 into P of E over B2, then which is divided by, out of three properties, that is P of B1 into P of E over B1, then plus P of B2 into P of E over B2 plus P of B3 then into P of E over U over B3. Then we have to apply the values, respective values. Here P of B2, here P of B2 is 0.35, P of E over it is 4%, 0.04 over 0.25. First one is 0.25 into 5%, 0.05 plus 0.35 into 0.004, 0.04 only, plus 0.40 into 0.02, which is equal, top multiplication is 0.0140 over, here the multiplication is, here multiply this, multiply and add them, simplify, we get 0.0345, which is equal 28 by 69, which is equal approximately about 40.6%. It is chance is 40.6% chance is the defect volt selected from second box, that is the asked questions. Next question, look at here. Look at this question. In a test, examinee either guesses, copies or knows the answer. Three possibilities: guessing or copying or knows the answer to a multiple choice questions with four choices. The probability that he makes a guess is, and the probability that the copies an answer is, given that the probability of his answer being correct when he copied it is. What is the probability that he actually knew the answer to the questions? That means, well, about his knowledge only he got this answer, considering the probability that his answer is correct if he copied it. Look at this. The answer. Let A1 be the event that the examinee guesses the answer, guessing the answer. A2 the event that the copies the answer, and A3 the event that he knows the answer. And also let A be the event that he answered correctly. Then we continue. We have assumed here that the events A1, A2, A3 are mutually exclusive and totally exhaustive. Now, what is P of A over A1? That is, again, it is responsible to take the probability of answering correctly, given that he knows the answer as 1. Then here P of A over A1 is 1. We have to find P of A3 over A by Bayes theorem, and hence required the probability is P of A3 P of A3 over A equal P of A3 into P of A over A3, then in denominator here P of A1 P of A by A1 plus P of A2 A over A2, then P of A3 P of A over A3, P of A over A3. Now we'll apply the values. Here P of A3 is half chance given. half into 100% because P of A by A3 is 1 divided by 1 by 3 probability of P of A1 into 1 by 4 plus 1 by 6 into 1 by 8 plus 1 by 2 into 1, which gives, after simplifying, we get 24 by 29, which is equal 82.3% approximately. What is that? And you have to find what? Look, considering the probability that his answer is correct, if he copied it, it is, the chance is 82.3%. Next question. Newly constructed bridge may fall down either due to wrong designing or by inferior material used in construction. Both chance is there. First, it may fall due to wrong design or due to false materials. The chance that the design is faulty is 10% and the probability of its collapse if the design is faulty is 95%, and that due to bad materials is 45%. If the bridge collapses, find the chances that it was due to wrong designing. Look at this. If E1 be the event due to wrong designing and E2 be the event due to inferior material used, then E be the event that is collapses. Therefore, the required probability is equal to probability that the bridge collapses and the chance that it was due to wrong design. We'll calculate that. Here, P of E1 by E equal, by Bayes theorem, P of E1 into P of U over E1 over M, starting with E1, P of E1 into P of E by E1 plus P of E2 into P of E over E2 plus P of E3 into P of E over E3. Now we'll apply the values. 1 over 10% into 10% means this given as 10%. It is 10 by 100 is 1 over 10 into 95%, 95 by 100, which is divided by 1 over 10 into 95 by 100 plus this third is not necessary because only two options here. Then second one is 9 over 10 into 45 by 100, which is equal, by simplifying, 95 by 500. is equal 19%. What it means? That means that the probability that the bridge collapses and the chance that it was due to wrong design is 19%. Next question, look at here. A man is known to speak the truth 3 out of 4 times. He throws a die and reports that it is a 6. Find the probability that it is actually 6, because he may tell lie or truth. But in this condition, what is that? In a roll of die, let E1 is event of rolling a 6, E2 event of not rolling a 6, both chance. That is true and lie. E is the event that the man reports the result as a 6. Then P of E over E1 is the probability that the man reports a 6 occurs when 6 has actually occurred. That is true. The probability that the man speaks true, it means. Second one, P of E by E2. Probability that the man reports that is 6 occurs when 6 has not actually occurred. That means the probability of that the man does not speak the truth. Probability of getting a 6 given that the man reports is to be 6, that is by Bayes theorem, which is equal, simply you do that answer, 1 by 6, that is this is a 1 by 6 is 0.125 over 0.125 plus 0.003. That is true and lie here. This is equal no, this we are getting wrong way. Then we'll do the answers here, which is equal 3 by 4. First here, look at this. 3 out of 4 times. That means a man speak truth 3 out of 4. That is 3 over 4 over into 1 over 6. What is 1 over 6 here? You are rolling die, he sees 6, it is really. Then 3 over 4 into 1 over 6 plus 1 over 4. That means not 3 over 4 is 1 over 4 and 5 over 6, which is equal, simplifying, 3 over 8. So far we discussed some interesting problem regarding Bayes theorem. We have done. Please subscribe our YouTube channel.